Today in class, we talked about perpendicular bisectors and how to construct them. We talked about perpendicular bisectors in Unit 0, and what we learned in Unit 0 was to make a perpendicular bisector, we got to hit the midpoint, and the line has to be perpendicular to the other line. So if this slope is down 1, 2 over 1, 2, 3, 4, 5, down 2 over 5, I got to go up 1, 2, 3, 4, 5 over 1, 2. So I got to do the opposite reciprocal. So we get a perpendicular line through the midpoint. Now we're going to construct a perpendicular bisector. So that's our goal. How could we construct this using circles and our construction tool? So I'm going to skip right to the notes. So a perpendicular bisector, again, is a line or a segment that goes through the midpoint and is perpendicular to the segment we're trying to go through. So all the points on the perpendicular bisector are equidistant from the endpoints. So if I had a point here, P to here is the same as Q to there, right? No matter where I am here, P to there is the same as Q to there. It's always the same distance away. So the midpoint, this line is the same distance as this line. So any point on this line, it would go on forever, is the same distance away from P and Q. So how we construct a perpendicular bisector is we just need two circles. Make a circle from one endpoint and go to the other one. So circle centered at A to B. Then you want to go from B to A. Because A to this point, right, that's the radius of circle A. And then since circle B is the same size, B to that point is the same distance. So this point's the same distance away from A and B, so is this point. So if we connect them, we'll go right down the middle. So we just created a line. It hits the midpoint, so I'm going to label this with an M, just for midpoint. And we just created the perpendicular bisector of AB. So to practice this, maybe the line's going the other way. We just got to go P to Q, Q to P, boom, connect it with a line. We just found the perpendicular bisector of PQ. Pretty easy construction. It's just two circles. One thing I want to point out is that we don't have to go all the way over there. Anytime the circles cross, as long as there's the same size, we would create that perpendicular bisector. If they don't cross, right, we don't have it, so they got to cross. Now, it's hard to make circles the same size without like a segment to make the same radius. So the easiest way to do it is just always go from one endpoint to the other, and then you'll always get two circles that are the same size. But I did want to show you like you could do it where the circles are smaller as long as they overlap, but they always got to be the same size. If the circles are not the same size, and we talked about this error in class, right? These circles are not the same size. Ooh, that's not going to hit the middle. It is perpendicular, but it's not hitting the middle. So the circles have to be the same size. So for the cool down, just got to do one. We want to try to go right down the middle of this hallway in between the two lasers. So how would we find the middle of the two lasers? We want to go down the middle so we don't hit the lasers in the hallway.